Okay, P equals MP is it's not part of the spec, but I think it's an interesting thing to be aware of. So it's actually one of the Millennium Prize questions, which means basically if you solve this, you get £1 million. So yeah, have at it, have a go. But what it's related to everything we've talked about so far in this small section of video. So for some intractable problems, a solution can actually be verified in a reasonable amount of time. So while you can't come up with the solution itself, if you, in that time given a computer, if you give the computer the answer, it can actually check it's true relatively quickly. Okay, so let's say let's try and simplify this. So if you said you wanted to work out what the shortest distance was between here and the other side of Europe, okay, let's say, I don't know, South Italy or whatever. Let's say we're going driving from here to South Italy. To actually test every possible route, every direction, via every road, it can be very difficult to do, okay? However, if I know what the actual answer is and I give it to the computer, while it couldn't come up with a solution in a polynomial amount of time, okay, because it's an intractable problem, it could verify that solution in a reasonable amount of time and say, yes, that was the quickest route. So because of that, some of these problems, some of these intractable problems are known as NP type problems, okay? Now, tractable problems are called P type problems. So think of them in terms of P equals polynomial, NP equals non-polynomial. So the challenge of computer scientists is to prove, one way or another, if the class of problems known as NP or non-polynomial problems can actually be reduced to polynomial problems. So it's known as the P equals NP challenge. Okay, so the question is whether or not for all problems for which an algorithm can verify a solution quickly, so they can verify that the solution is true in a polynomial at a time, could you also find that solution quickly? Okay, because since the former, so verifying a solution, describes your non-polynomial problems, whilst finding the solution describes your polynomial problems, the question is equivalent to asking whether all of the problems that we currently think are in NP are actually also in P. It's just the approach we're currently taking to solve them. All right, because if you've got a problem that you can check it's true in a reasonable amount of time, surely you could find that answer in a reasonable amount of time. Okay, it's considered one of the most important open questions in mathematics and theoretical computer science, as it has really big, far-reaching consequences in maths, biology, philosophy, and cryptography. Things as mad as encryption could cease to exist to what we're seeing today if this was solved, because it might be that decryption and cracking problems that are non-polynomial problems at the minute, they're intractable problems. If this was solved, you never know, you might find a solution that, let's say a really high level encryption technique. It's a non-polynomial problem to like brute force hack everything to see if it's the right, to find the right answer. But if you give it the right answer, it's quick to check that it's correct. So you can imagine the impacts that solving this, if it's not even solvable, could have on cryptography. But yeah, so this is known as P equals NP, and I just thought it's something that comes up in computer science, especially if you end up going on to study at a university. And I just wanted to give you the heads up on what they're talking about.